Welcome students. Today we are going to study chapter 4, that's elasticity of demand. Now the word elasticity is related with flexibility. So you remember the word flexibility changes whenever you learn elasticity. We would begin this chapter by reading this slide which is about a British economist, Alfred Marshall. He is generally credited for defining this concept of ED. Now, this is the symbol which I have used for elasticity of demand in 1890. But it was the German statistician Ernst Angel who published a paper in 1885 showing how changes in income alter the level of demand. So this slide is just an introductory information for you to know the contribution which has been made by these various economists on elasticity of demand. Let's understand this in the further slide. Now, when we begin with elasticity of demand, remember the word sensitivity, flexibility. As consumers, we are all sensitive to price. In fact, sometimes we look at the price first and then decide whether we need to buy the product or not. Like the other day, I was just going with my friends and then we were planning to order coffee and we thought, should we really prefer this coffee or not, because the price was too high. So, you know, you have already studied a chapter on utility, price matching with utility. So, is it really worth paying that price? So, we are all, let us agree that we all are price sensitive at some point of time in life. Now, this is what price elasticity of demand is about. For any change in price, demand may change. Now, this is the important sentence which you have to remember. Demand may change. So, demand is a dependent variable, price is a independent variable. This is what you have already studied in chapter 3. So, for any change in price, demand may change proportionately, more than proportionately, less than proportionately, or not change at all, or it may change infinitely. So basically it is the responsiveness of demand to price which is measured under elasticity of demand. This is a formula of how price elasticity, because it's a numerical concept, how it can be calculated. So the formula is given to you here. It is the percentage change in quantity demanded of X upon percentage change in price of X. So, percentage change in quantity demanded of X upon percentage change in price. Now, please remember, price will be in the denominator and quantity will be in the numerator. Never forget this. So, we are measuring how much the demand is responding to a given change in price, and it is measured in percentage. So it is the degree of responsiveness of quantity demanded to the change in price. The same formula can be further written in symbols like this. The percentage triangle stands for delta. So percentage delta Q dx, quantity demanded of X, upon percentage delta, which is change, Px. So delta Qx upon delta Px. Now, there are different types of price elasticity of demand. Before you go into this price elasticity of demand details, go back to this, we'll go back to this formula. See, percentage change in demand of X upon percentage change in price. Let's say that the price of petrol goes up by 2%. And the price of or the demand for petrol falls by, because the price have gone up by 2%, the demand for petrol will fall by, let's say, 8%. So 2% price, 8% demand. What will you do? 8 divided by 2. Because the demand is changing by 8%. Price is changing by 2%. So 8 upon 2. What is the answer you get? 4. So 4 is your answer for price elasticity of demand. Now this 4 is called as what? We call it coefficient of price elasticity of demand. On the basis of what answer you derive by using this formula, These are your conclusions, which means you have to classify the type of price elasticity of demand. So on the basis of the answer that you get, you should be able to classify the product's elasticity. To classify the product's elasticity, you need to know the types of price elasticity of demand. There are 5 types of price elasticity of demand, and the first one is given in this slide, which is unit elastic demand. Now, when can we say that price elasticity is unitary? Or when can we classify the product's elasticity into unitary elastic? When your answer is equal to 1. So, when the change in price, what is the meaning of this equal to 1? It means when change in price brings about exactly proportionate change in quantity demanded. So, if there is a 1% change in price, there is exactly 1% change in demand. Or as we took the previous number, a 2% change in price, when it brings 2% change in demand, your answer will be lying here, because 2 divided by 2 is equal to 1. So don't forget, percentage change in price and percentage change in demand will be same. The diagram for unitary elastic will be downward sloping, like what you have studied in your chapter 3, law of demand. So it is downward sloping, convex to the origin. This is how the diagram for unitary elastic demand would look like. The second is relatively inelastic demand. This is the second type of price elasticity of demand. When can we classify the product coming in this category? When our elasticity of demand answer is less than 1. Less than 1. So less than 1 means greater than 0 but less than 1. 0.1, 0.2, 0. It can be from 0.1 till 0.9. 0.99 also. So, when the elasticity is less than 1, what does it mean? It means the change in price is bringing less than proportionate change. Remember this word, this sentence. Less than proportionate change in quantity demanded. This means that the percentage change in demand is less responsive to the percentage change in price. The diagram for relatively inelastic, as you see in the slide, is very steep. Remember the word steep. So all the products which come under relatively inelastic demand, where the value, coefficient value is less than 1, will have a steep slope demand graph. So this is how relatively inelastic demand can be remembered. The third, relatively elastic. Now what we discussed before this? We discussed, students, relatively inelastic. And now we are discussing relatively elastic. So that word in is removed. Relatively elastic. When our answer is greater than 1. So the example which I had taken up, where 2% change in price of petrol is bringing a 4% change in demand, my answer was on 8%, right? 8 upon 2. So my answer was 4. So 4 is greater than 1. That means your answer is classified under relatively elastic demand. Now what does it mean? Change in price will bring what? More than proportionate change. So when you are studying this, you can go back to this slide and remember, underline this word, relatively inelastic mein, it is less than proportionate change. So in both the cases the price is changing, but in relatively inelastic the change in demand is less than proportionate. Whereas here in relatively elastic the change in demand is more than proportionate. So you can always remember, in elastic there is less than proportionate change in demand to change in price with respect to change in price. Whereas in the current slide which I am discussing, relatively elastic, the change in demand is more than proportionate. So the diagram for relatively elastic is, as you see, very flatter in slope. In the previous case, what did I say? Steep slope. Now the word I am using is flatter in slope. So don't forget, relatively elastic demand, the diagrams are flatter in slope. The meaning of this is that, see, the change on the price is measured on the y-axis. So the change in price will be comparatively in a smaller proportion, whereas the change in demand will be in a comparatively larger proportion. Therefore, that distance is comparatively wide, such that it spreads across the x-axis. The fourth type of price elasticity of demand is perfectly inelastic. Now see the word perfectly. When can you say that the product comes under perfectly inelastic demand? When the coefficient value is 0. So when can we have a 0 value? Correct? 0 divided by any number will give you what? Will the answer be 0? It means there is no change in quantity demanded. So even if the prices are changing, the change in the demand for a specific product is not getting affected. So it is a case of price insensitivity. Consumers are not at all affected by the change in price. So those products and that situation comes under perfectly inelastic demand. How will be the diagram for perfectly inelastic demand? As you see, it's a vertical line. This vertical line is fixed at 50. So suppose for a given product, the market demand is 50 units. Then if you look at the y-axis, where we have numbered price starting from 0 till exceeding till 100, so whether the price is moving from 10 to 50 or 60 or 100, the quantity is fixed at 50. So this tells you that there is no change in the quantity demanded and it has to be classified as perfectly inelastic. Inelastic means rigid, not changing. The last type of price elasticity of demand is perfectly elastic. Now this is the opposite. Previously what did we discuss? Perfectly inelastic. Now we remove the word in and it becomes perfectly elastic. So what happens in perfectly elastic? The elasticity will be infinite, infinity. This is a alpha symbol which is used for infinity. Now when can our answer be infinity? When any number you divide by 0, means even if the price is changing or not changing, but we don't use the word not changing because we say there is a slight change in price, a fraction. Like in some cases you find price of petrol, it changes by 0.20 paise or 0.25 paise. So when the change in price is very slight, but the change in demand is infinite. So infinite change in demand is a case of perfectly elastic demand. And how would be the diagram? Let's see in the next slide. It's horizontal. The previous was vertical, this is horizontal. Now see, the price is at 60. Suppose if the price falls to 59.75 paise or 59.80 paise. So the change in price is very minute, but the change in quantity is unlimited. It's moving from 30 to 40 to 70 to 100. So change in quantity is unlimited. Now here I have given you an example. This example is for self-practice where a company sells 50 pens at rupees 10 each. And when it brings down the price to rupees 5 per pen, it is able to sell 100 pens. Now, whatever you have listened and understood till now, you have to apply that and test yourself whether you are able to solve this question or not. I will just tell you the steps that you have to follow for solving this. First of all, I have already written it down. This is the way you are going to solve when a numerical question on price elasticity is given. In this question, first you will have to find out what are the prices given. As you see, I have mentioned P as 10 and P1 as 5. So P is my original price. What was the price of the pen given? 10, rupees 10. So P is 10. Then the price of pen has come down to rupees 5. So the new price P1 is 5. So you get P and you get P1. Next is Q. Now when the price of the pen was rupees 10 each, how many pens was the company able to sell? Sell means we understand that people have demanded it. So Q, quantity demanded, is 50. So Q is 50. Then when the price had come down to 5, the quantity went up to 100. So it's 100. Now what you have to do in the formula? The formula was given to you in the beginning. So you go back to that formula which says percentage change in quantity upon percentage change in price, and see what answer you derive. Practice it. I will also solve this on the whiteboard so that you are able to understand how you will solve this particular question. So students, as we had seen the sum in the slide where the price of pen was given, I have written it down and I would be explaining you. So price of pen was given as 10. This was the original price of pen, and the change in price, the new price of pen, I have labeled it as P1. So always remember, P is the old price, P1 is the new price. So it is 10 and 5. When the price of pen given in the question was 10, the quantity was 50 pens demanded, and when it comes down to 5, the quantity demanded is 100. So you have two different prices and two different quantity. Now our formula, if you see, our formula is here, correct? This is our formula. Price elasticity is delta Q upon delta P into P upon Q. So how do you get delta P? Delta P will always be P1 minus P. So 5 minus 10, that gives you minus 5. Because minus 10 is a greater digit, minus sign gets carried in the answer. Delta Q is Q1 minus Q. So 100 minus 50, you get the answer 50. Now you just substitute the values. So delta Q 50, delta P minus 5, P is 10. So you write that 10 as it is. Q 50, you write as it is. Now cancel, 50, 50 gets cancelled, 5, 2s are 10. I have not put minus sign over here. So the minus sign can be ignored in price elasticity. I repeat, minus sign can be ignored. The minus sign only stands for inverse relation between price and quantity. So your answer is 2. So what do you conclude? The product comes under relatively elastic. Those 5 types of elasticity. So this is how you need to use, practice it, give any dummy values and try to practice this sum. So students, you have understood how I have explained you on the whiteboard how you have to calculate the values to derive the price elasticity of demand. Now there is one more sum which I have given you in the next slide, as you see here. But here you will not use the same method which we have just seen for the previous sum. Look at this question. We have to assume that there is an increase in prices of Maruti 800 by 10%, which leads to decrease in its demand by 15%. Then price elasticity will be dash. Now because here it is already given in percentages, so what you will do? Just substitute the values. So percentage change in demand upon percentage change in price. So demand is how much? 15%. Students get confused. They see 10% and demand and they sometimes write 10% in place of demand. So I would request you, read the question very carefully. See, you can underline when you are reading or write it down somewhere. Price of Maruti 800 has increased by 10%. So P, price 10%, demand 15%. So what is our formula? Demand will always be in the numerator. So 15 upon 10. What will be your answer? 1.5. So elasticity is 1.5. Now once you get your answer, what is your next step? Taking you back to these slides. See, 5 types of elasticity. What have I done is, I have prepared in the next slide a table in which all the 5 types of price elasticity are mentioned. Something like this. So this is like a revision. Whatever you have memorized, whatever you have calculated, now in this one chart, you can just revise it. So there are 5 types of price elasticity: perfectly inelastic, relatively inelastic, unitary elastic, relatively elastic, and perfectly elastic. So students, you can see the middle part. The middle is unitary elastic. And then we have 2 parts above. Both are inelastic, perfectly, relatively, perfectly. Now what is given in the second column? The coefficient values, which was already explained to you. What if your answer is less than 1? You will declare that the product comes under relatively inelastic. Now the symbol that is used for price elasticity here is capital E and small p. So meaning is nothing but it's a symbol for price elasticity of demand. In the third column, I have given you the numerical values. Similar to this was the previous sum. So everywhere the numerator is the demand. So 0% upon 5%. Actually there is no percent, it should be 0. So 0 divided by 5%. That means if the price is changing by 5%, the demand is changing by 0. So it is, what will be the answer? 0 divided by 5? 0. And if your answer is 0, what will you declare it as? Classify it as relatively inelastic. You will find this is in case of life-saving drugs and medical services. Now the last column is very important, because in the last column I have mentioned the examples of products or the category of products which will get classified into this elasticity based on elasticity values. So you will find, students, that all necessity and essential things in life, they go under inelasticity. The more the product necessity or essential in your life, the more you will be price insensitive. So see, life-saving drugs and medical services. What happens? People pay whatever is the price to get these services. So that is why they come under perfectly inelastic. But if you see necessities like food, different types of food, okay, different types of clothes, these all comes under necessity, where you can compromise or you can look for some substitutes which are cheaper. So these necessities will come under relatively inelastic. It also means, students, that people will not buy more when the prices come down. In necessities, you can take one example of fruits or vegetable. Suppose if the price of fruits fall by 10%, it doesn't mean that people will buy quintals and quintals of fruits and stock it. So fruits, vegetable, perishable product, even if the price come down, people will buy more, but not so much that the answer goes in greater than 1. So therefore, 10% change in price is bringing 5% change in demand. So our answer is less than 1. Are you understanding this? So if you look at this third case, I have kept it blank, because you very rarely get products coming exactly in unitary elastic. So 5% price badla, to 5% ही demand बदलता है. This will not happen always. Usually our market will either fall into inelastic category or elastic category. So here we call this unitary elastic as a divider. It is dividing between the inelastic and the elastic category of products. Comforts, luxuries come under relatively elastic. So branded products, if there is a 5% discount, They will be able to get 10% sale because people are more responsive to such type of price reductions. Therefore, season sales become very, very popular in the market because they come under relatively elastic demand. Look at the last one, panic buying. Now, when I was explaining you perfectly elastic and I said that the demand is horizontal, which means the people will go on buying or there will be unlimited demand in the market. We put it under a very extreme case, panic buying. Panic buying is like there is a swine flu. So everybody will go and start buying those face, mask to protect themselves. Or there is some type of epidemic and there is some vaccine which people have to take to protect from that epidemic. So there will be big queue outside the hospital and dispensaries. So that is an example of perfectly elastic. Oh, that reminds me, demonetization. Do you remember the amount of queues outside ATM and banks? In fact, outside banks for changing the currency, that was an example of perfectly elastic demand. So I hope students you all have understood whatever I have explained you with respect to price elasticity till now. Now we are moving to the next method of measuring elasticity of demand, and this is called Marshall's method. This is an alternative method. From this method also you can classify and find out the product's elasticity. This is a method in which we are connecting the elasticity with revenue. What is total revenue or outlay? It means how much people spend. So remember that in this Marshall's method, we are calculating the elasticity of demand based on expenditure or expenses. Now to understand that, Marshall has made use of some numerical values. Let us understand it. You will see here price is given 60, 50, 40. Quantity demanded given 100, 120, 150. And then last column is total outlay. How do you get this total outlay? P into Q. So 60 multiplied by 100, 6,000. 50 multiplied by 120. So you multiply, price multiplied by quantity gives you total outlay. It's as simple. Let's say if one glass of tea is costing you 10 rupees and you order 3 glasses of tea. So what will be the total expenditure? 30. Price multiplied by quantity. So it is that simple, P into Q. And this will give you total outlay. Now what Marshall said is that when the price is falling, you can see here price is coming down. Correct? 50 to 40. Quantity demanded. Is the quantity demanded rising? Yes. From 100 to 150. So price is falling, demand is rising, but total expenditure is constant, 6,000. So he said that when the total expenditure is constant, then you conclude under revenue method that the elasticity is equal to 1. You don't have to do that delta Q upon delta P, no calculation. Just multiply price into quantity, check the values. If your total outlay remains same, then you say it is a case of unitary elastic. Let's go ahead. The second category. Here the same example is taken, but there is a difference. Your total outlay is falling. Earlier it was 6,000, then it is coming down to 5,500 and 4,800. What does it mean? Person's expenditure is going down. Now when a person's expenditure is going to go down? When the people will buy less. But here the quantity demanded is not coming less, it's more, 100, 110, 120. But why is the total expenditure falling? It is because if you see the change in quantity demanded is less. Let me take you to the previous slide. See here. Here the change in the quantity demanded from 100 to 120. From 120 to 150. Matlab proportionate change in demand. So when the change in demand is the proportion, if this proportion, let me take you to the slide which I was discussing now here. See, this change in proportion is less. That means demand is increasing but by a smaller proportion. Therefore, total expenditure is coming down. So what do you declare it? It's a case of relatively inelastic demand, which means that when the price is falling, the market demand is responding to that fall in price, but the total expenditure is also decreasing. So fall in expenditure because of fall in price. This happens when the prices start falling. This will only happen when people are not buying much more than what is required. So if you were ordering a cup of or a glass of tea which was costing you 10 rupees, you ordered 3 cups of tea or 3 glasses of tea, you spend 30. But when the price comes down to 5 rupees, you may still buy more, but you will be spending less than 30 rupees. Suppose if you order 3 glasses of tea, but the price per cup of tea is 5 rupees, what will happen? You will not be spending 30, right? So when the fall in price will increase the demand, or maybe you can order 3.5 or 4 cups of tea, still you will be spending less. So this is because it is a necessity product. That is what happens when electricity rates drastically come down. People get an advantage in their electricity bill, provided they increase their consumption not beyond limit. Unfortunately, what happens is, when it comes to comforts, luxuries, and when things become cheaper, people start spending or people start buying so much in quantity that they'll end up paying a higher bill. Look at this case. Here, if you look at total outlay, it is 6,000, then it is going up to 7,500, and again it is increasing to 8,000. Now, why is the expenditure increasing? Because if you notice, see the quantity demanded, see the increase, 100, then from 100, 150, and from 150, 200. So there is a large increase in the quantity demanded for a given change in price. And therefore, we declare it as a case of relatively elastic. So what did you understand, students, in this Marshall's method is that when people are, or when consumers are more reactive, more responsive to the price change, they will be spending more. Their expenditure will be increasing. So we understand that this is a case of relatively elastic demand. So relatively elastic will always take place for comforts, luxuries, or all those products where people are buying more in quantity, or the proportionate change in demand is much more than the change in price. Whereas in case of relatively inelastic, whenever prices fall, the benefit will be enjoyed by the consumer, because being necessity, the proportionate change in demand will be comparatively less than the proportionate change in price. So I hope, students, you have understood this 3 different methods of measuring elasticity given by Marshall, which is called as revenue or outlay method. Now we come to yet another method of calculating elasticity, which is graphical based. Because there are graphs which you have seen when we started in the beginning, we had that steep slope graph and then flatter slope graph, you remember? Perfectly elastic, perfectly inelastic. So when there is a diagram drawn, then how do we measure elasticity? So there are 2 concepts related to graph, as you see in this slide: arc elasticity and point elasticity. I have mentioned here very clearly what is it that you have to remember to differentiate between arc elasticity and point elasticity. So arc elasticity mein we are measuring elasticity over a segment of the demand curve. Over a segment of the demand curve. Whereas in point elasticity, we are measuring elasticity at a particular point on the demand curve. So this is something which you have to keep in mind. Now how do we understand this? Let's understand in the next slide. Here we have given you the formula of arc elasticity of demand. So it is always used, remember, when the change in price and quantity are discrete. There are discrete matlab not in decimal but in absolute number, like a price of petrol was 80 rupees and it has become 85. So that change is of 5 rupees. So when the change in price is in absolute number, or there's a large change in price, which is of course over a longer duration of time, then we will be using what is called as arc elasticity method. It is basically used to find the elasticity at the midpoint of an arc. What is an arc? It is a point between any 2 points on the demand curve. So you have to draw the diagram, okay, as I'll be drawing the diagram, and you will see that there are two, or I think we'll take a next point where you can see there are 2 points, and on those 2 points you can measure this arc elasticity. This is the formula which is given to you, Q2 minus Q1 divided by Q2 plus Q1. Again that is a fraction, divide by 2 divided by P2 minus P1 upon P1 plus P2 divided by 2. Now this 2 gets cancelled, I will explain you, and this is your actual formula. So which formula you have to remember for arc elasticity? You can remember the next formula. I think this is more easy. Q2 minus Q1 upon Q2 plus Q1 into, this dot stands for multiplication, P1 plus P2. Now see, it has become opposite. Q2 minus Q1 upon Q1 plus Q2 is ka opposite. P1 plus P2 upon P2 minus P1.